Let's make the quicksort algorithm generic. This is Daniel and you are going to get coded. Here I have the code from this specific video, so make sure you watch this video first before jumping into this one. Because on the right side here I have all the code from that one, and this is how to implement quicksort in C# and how to split this implementation into multiple methods. So make sure you watch that video. If you have, welcome back, let's continue. So the aim of this video is to make the implementation of the quicksort generic. So right now you can see that I'm able to pass only numbers, so only integers, array of integers, but I want to pass any type. I want to pass characters, I want to pass strings, custom objects like car, class, cat, anything. So it has to be generic. Right now is not. In order to make it generic, we need to transform this code. And we have on the left side 4 steps. So I'm going to explain all these steps one by one. Why do we need them? And then I'm going to implement them again one by one. So use the T type. We need to use the T for generic for each one of our methods. So right now we cannot just use int, but we need to use T, which is used for generics. The second step, add the condition that it must implement the iComparable interface. So this is the condition that we want to apply on our generic methods. So every single time you want to implement a generic method, it has to implement some conditions. It has to comply, satisfy, or pass some conditions. In our case, we need to use this iComparable interface because this interface provides us with a method that we need to call in order to compare two items. And we can see that method on the right, not on the right, but on the left side, the third step. So make use of the compareTo method. This compareTo method comes from iComparable. And if you are not familiar with interfaces, I can give you like a short and brief explanation of what an interface is. So in essence, when you think about an interface, is something like a class, but you have to implement it. So an interface contains methods, for example, that you have to implement. So if I want to force you to implement some methods, I can create an interface. This is why you need an interface. I want to force someone to implement certain functionality. In our example, iComparable has a method called compareTo. And this method we are going to use when we want to compare two items. So this is the idea of actually having interfaces, okay? And interfaces are different than classes because an interface, again, has some members which you need to implement, but a class offers the members and also the implementation. Okay, so the last step, the fourth step, is going to rename the numbers parameter to array. So to make it more generic, it makes sense to also rename the parameter to something else which is more generic. I chose to have array. So these are all the steps, and if I scroll down a little bit, you can see the whole code. So this is the code that we will end up with, but I'm going again to implement it one by one. So let's start with the first step. So the first step is to make use of the T type. So after the name of the method, you need to have T, and right now this is generic. And we need to specify or to choose which parameters has to be generic. So in our case, we don't want an int numbers, we want T numbers. And this T again represents the type of the array. It can be int, it can be double, it can be report, it can be any custom class. So this is the idea. And whenever you want to transform a method into a generic one, you need to think about what conditions you want to have. So in our case, we want to have the condition of iComparable interface. So all the items in this array have to implement the iComparable. So I'm going to press end and then enter, and I'm going to say where T implements iComparable. So this is the idea. And right now, whenever we want to call Quicksort and we pass the numbers array, that numbers array has to implement iComparable. If it doesn't, then we are not allowed and we are going to get a compile time error, meaning we are going to get the red squiggly line underneath, telling us that that collection doesn't actually implement iComparable, or the type of that collection doesn't implement iComparable. Okay, so the first two steps done. But right now we have two errors. We have two things that don't work. Numbers I less than pivot, numbers j greater than pivot. So right now we are not able to actually compare items like this. So we cannot use the less than and the greater than symbols to actually compare these two items together. So we need to make use of the compare to method. So I'm going to create the first one, or to transform the first one. So numbers I, and this right now exposes the compare to method. So I can say compare to pivot, and this has to be less than 0. Why is that? The compare to method returns some values. And let's imagine this. You have two items, okay? Number 1 and number 2. If number 1 is less than number 2, compare to method is going to return a negative value, a value which is less than 0. If number 1 is bigger than number 2, then we are going to return a positive value, meaning a value which is greater than 0. If these two are equal, then the compare to method is going to return 0. So this is how compare to method works. And in our case, we want less than 0, so the first item has to be smaller than the second one. Okay, this is how compare to works. And let's try to transform this for the next one as well. So compare to pivot, and this has to be greater than 0. So as you can see, we still use the same symbols, so less than for the first one and greater than for the second one. We still do this, but right now we need to use the compare to, and we need to compare that result with 0, so not the items in between. Also, I could have done this very thing before in the Quicksort algorithm, but I chose not to because I wanted that algorithm in that video to be a little bit simpler. But right now we need to make it more complex because it has to work with many different types. And I can show you something. So if I just make some space here, and I can, I don't know, I can put 3 here. If I put dot after 3 and start typing, you can see that 3 has a compare to method. So by default, any number, any integer has a compare to method. So we can say var result equals 3 dot compare to 4. So this works with numbers. But again, I chose to not have this implementation right at the beginning because it was way too much, way too complicated. But right now we need to make use of it. So if you want to change that to switch to compare to, you are welcome, but this is what I decided to do. Okay, so I got that out of the way. We can continue on with implementation. So step 1 is done. Step 2, I added the condition. So you can see the condition over here. Step 3, make use of the compare to method. I have rename the numbers parameter to array. So I'm going to click on this and then Control R, and I'm going to type array and then enter. And you can see all the references of that array parameter have were changed. So we managed to rename the whole thing. So right now this looks good. I will try to drag this back to the right, and let's try to compare it one more time to make sure that everything looks nice. And again, we don't need to change ints here because these are the indices, so we don't want to change those. They remain numbers. Okay, so everything looks nice. Let's continue. Rename the array in the other function as well. And besides that, we are going to use the t type as well. So we need to apply all the steps again for the first one. So let's see if we have remembered the steps. So step 1, we need to make it a generic type. So we need the t between angular brackets. Afterwards, we need to rename or to change the type to t. And right now you can see that I have the error. So this doesn't implement the comparable blah blah blah. So all that which I explained earlier. So we need to have the condition. Well, all the items here implement the comparable of type T. And now we can just rename numbers to array. So you can see everything works fine. We don't have any errors. So let's try to continue. And that's it. So it works again with numbers. So let's see that in action. I will press F5 and let's try to see the result. Hopefully you'll have all the items sorted. So everything is amazing. We can press any key to stop. Let's move on. We can create two more arrays, one chars and one strings. So as you can see here, I have an array called letters and an array called names. Both of these are initialized with some values. So let's do that. I'm going to create these two arrays after the numbers array. So var letters is going to be new square brackets, and this is going to be F G, and I'm trying to comply with the example, so I'm trying to use the same values as in the example so that I can have the same results as in the post, and not as, but as in the post. Okay, and then var names. And also, if I talk too fast and too slow, please tell me. I need to know, and I need to find my rhythm, okay? So I know sometimes it's a little bit difficult to find a good rhythm, but I'm trying. So Peter, Alex, John, and Fred. And I remember right now a movie in which I heard Peter pronounce pizza, and I forgot the name of that movie. I think it was Hunger Games, but it was just so funny. Pizza. Nevertheless, okay, so we have these two arrays right now. We want right now to sort the array. So as we call sort array for numbers, we want to call sort array for letters and for names. So I'm going to press on Control C, and I'm going to copy and paste this line. So the second reference of numbers, I'm going to change it to letters. And the third reference to numbers, I'm going to change to names. So I'm going to have numbers, letters, and names. Okay, let's continue on. To keep our code dry, meaning to not repeat yourself, I want to extract the print array code to another function. So you can see right now here, I have a function, which is again generic. So again, generic functions or methods, in which I print the items in the array. So basically it's the same idea over here. Right now I print all the numbers from the numbers array, but in order to actually print all of them, I need to repeat myself. So I want to do something like this for each array. Right now I have 3 arrays, but I'm going to have, I don't know, 10 or 100. So you don't do this. In this case, we need to extract this specific function, this specific logic, into a separate function. So I'm going to do this before the sort array. So let's try to write this function over here. So this is called print array and is of type T. So public static void. This returns void because we just print to the console. We don't want to return anything. This is why I chose to have void. Print array of type T. Again, I want to pass the T. T square brackets an array. And then I'll have the same implementation. So let's try to copy this one over here, or even cut it from here, and we can paste it over here. And instead of numbers, I'm going to iterate over array, and I'm going to rename number to be more generic into element, as you see on the left side. So I'm going to press Ctrl RR, and I'm going to rename the number to element. Okay, and then I need a new extra line. So I'm going to implement this, or to write this down, and let's try to explain why I need this. So imagine you print the numbers, okay? So you print 0, 1, 3 until 34. Then you start printing the letters. So you are going to start with A and so on. But I want like a dividing space between them. So I want to print the items from the numbers, then I want some space, aka a new line, and then I want to continue on with letters and so on. So this is the actual idea of having a console.writeLine in this method, so that we can have like new spaces, new lines after each array. So we can now display the content of the arrays like this. So we can call print array and we can pass the array. So let's try to say print array, and you can see right now that I'm able to pass any type. So this is why we need to use generics, because we can pass numbers. Let's try to copy this line. So copy, Control V and Control C, and now Control V 2 times. And I'm going to say letters, and then I'm going to say names, just like this. And then I don't need this new line. So you can see right now, because this is generic, I can pass int, I can pass char, I can pass string. This is the magic of generics. So let's try to press F5 and see if all these arrays are sorted. And they are. So we have all of them sorted, the numbers are sorted, the characters are sorted, and the strings are sorted. Everything looks fine. So we can press any key and we can continue. So as I said, what about custom classes? What about an array of books? What about an array of reports? Right now we can pass any type, any custom type, because all of them are of type T. So let's try to create our own custom class and see how this behaves, okay? So I'm going to create my own class, as I say here. I'm going to create a class called book, which has only one property called ISBN. And pay attention to this. Based on this property, we are going to compare books, because two books are equal if they have the same ISBN. So if two books have the same ISBN, this is the unique identifier, this is the ID. If they have the same ISBN, it means that they are equal. So this is our logic, this is our requirement. And this is the class that we are going to implement. This is a very stripped down version of a book class, of a real book class, because in real life you have many other properties, such as, I don't know, title and author or authors, or you might have number of pages, so all these properties. But to make this example simpler, I can just use ISBN. So this is the only property that I am concerned about in order to implement iComparable. So I don't care about titles and authors. So if two books have the same title, it doesn't say anything, it doesn't express anything to me. This is not my logic. My logic is two books are equal if they have the same ISBN. So I'm going to create that property, and then I have a constructor to which I pass that property, or I inject that property, that value. Then I have Compareto, so this comes from the iComparable because I implement the iComparable interface. So again, pay attention to this. Whenever you want to have an interface right there, it means that you want to implement the interface. So this is like the terminology in programming. So you implement interfaces and you inherit classes. You cannot implement a class or inherit an interface. You know, it sounds a little bit odd and strange. So if you want to actually be well understood by others, you need to make sure that you have the right terms whenever you want to talk about specific parts of your code. In our case, we are implementing an interface. So we can say the book class implements the iComparable interface. And then we have the overridden version of the toString method. So I'm going to explain this as well, and then we can start writing this down. So the toString method comes from objects. So any object in C# has some methods, and I think in total of 3 methods, one of which the toString is. So we can override the toString method for any object. The default version, the default behavior of a toString method is to return the fully qualified name of the class. In our case, it will return quicksort.book. This is the fully qualified name of the class, and I hope this is what the toString method will return. So Quicksort or system dot something, but this is not what we want, because this is going to write down to print to the console the same thing for each item. So it's going to say quicksort.book, quicksort.book, and so on. So this is not our desired behavior. Whenever you want to print to the console an item, you want to override this toString method. And in our case, it makes sense to have ISBN. So I'm going to return ISBN to the console whenever I call toString method. Okay, so this is the class. Let's try to implement it. Make sure you implement this specific class after the class program. So this is the first curly brace from the program, and this is where it ends. So make sure you are afterwards. So you need to have one extra after this book class. So class book, and I'm going to create the ISBN property. So I can say prop and then tab. The first one is the type. I'm going to say string, and afterwards I'm going to say ISBN. Right now we need to create a constructor, because I don't want it to write it by hand manually. I can say control dot, and then I can generate the constructor. Right now you can see that I have checked the first property. So ISBN is checked. We can just press enter, and you can see that constructor over here. So we don't have to write it by hand. Then we want to implement the iComparable. So we need to go right here after the name of the class, and then we need to say iComparable of type book. So this book knows how to compare itself with another book, and we need to press control dot and then implement interface, and this is the compare to, and by default it throws an exception. So this is not our desired behavior. As I said, I want to compare books based on ISBN. So I'm going to say return ISBN dot compare to. Again, we need to make use of the compare to method. Other dot ISBN. And then the last thing that I want to do, I want to override the toString method. So we need to say override and then space, and you can see all the methods that are available to be overridden. So equals, get hashcode, and toString. We need toString. And this is the base implementation, the default implementation to return base.toString, which again returns the fully qualified name of the class. We don't need that. Instead of base.toString, I want to return ISBN. You could have done something else. If you have more properties, you can have like a string which contains the title, the author, maybe the year, something like more, I don't know, meaningful to a user. But right now, because I have only ISBN, I can just return that. So I'm able to actually differentiate between two books. So this looks nice. Let's try to continue. I'm going to create an array of books. I won't create a proper ISBN, just some dump ones. So we are going to do the same for the books array. So after names, I'm going to create books array. And this is going to be new square brackets. And I'm going to pass new book. And again, we need to use some dump ISBNs. For DS, new book. This is going to be 2ER. And the last one, new book. So here we are creating actually new objects, new instances of the class book. And then 31. Also, I have a tip over here. My intent with this video is to show you how to implement iComparable and how to think about it. So again, as with any video that I'm trying to make, I just don't want to explain, well, I want to explain, I don't want to show you all the things that I have to do and in 5 minutes I'm done. The intent of this video and the intent of my channel is to explain the actual things and how they work. Because if you don't understand, this is pointless. Because whenever you want to start working with a client or in a company, you will not have books and so on. You need to understand the meaning, the reason behind it, and you need a person like me who explains the code. So this is what I prefer for my channel, and I'm trying to explain everything that I write, the reasoning behind it, and everything. So again, the intent of this video is also to show you how to implement iComparable. And I say here, this interface isn't that difficult and using it is a breeze. So again, many developers have tended, I think, to look at interfaces like something, I don't know, intermediate. I still don't think that, or advanced. I still think that these interfaces are achievable, any developer can know those interfaces. So again, I'm trying to explain, I'm trying to go step by step and to show you all the reasoning behind my code. Okay, so we can just sort it and display it. So I'm going to sort the books and print the books. So the same, Control C, Control V, I'm going to say books, and then Control C, Control V, I'm going to say books over here. So you can see we have no errors whatsoever because these two methods are generic. Okay, so let's try to press F5 and see our books array sorted. So we have 2ER, 31, and 4DS. Everything looks amazing. And also you can find the source code on GitHub. So I have this code on GitHub for this specific generic quicksort algorithm, and I have a separate repo, a separate repository for the first one. So I have in total of 2 repositories for both projects. So you can clone them and you can use them how you want them, and you can extend them, or maybe you can even create a pull request if you want to help me, if you want to extend the functionality, or you have found something that is not right, okay, or you want to make it more, I don't know, implement it better. Also, I have told you many times, you should strive to actually create many methods, many functions. So to not have like a long method with everything. And we could have done this. We could have done here something like that. We can have like a swap function, a swap method, to which we pass the array and the indexes. So we can pass like array and I and j, and we can do something like that. So this could have been smaller. Also, we could have done something here. So we could have extracted all of this functionality from here and name it like partition array, and we can partition that array. So you could have broken down this very method into smaller methods. But again, this is the starting point. This is how you should think. You have a long algorithm, you try to implement it in multiple methods, okay? So this is the quicksort. For me, it makes sense to have it as a separate function, as a separate method, because I'm going to call it many times. So this is a recursive method. Okay, so let's continue on with the conclusion. But should we use this approach? Well, I don't recommend so. And if you saw the first video, if you saw the quicksort video, you would know what I mean. And I'm going to create a new experiment in a future episode. So I'm going to compare this very algorithm with the algorithm provided by C#, provided by Microsoft. And that algorithm is in array.sort. And again, that is a more specialized version of sorting items. And I'm trying to actually compare and see how they actually perform. So performance and speed test. If you want to know about that, please click also thumbs up. Also consider subscribing. Right now my goal is to have 1,000 subscribers. And again, if you don't understand something in this code, please tell me. Please write down in the comments below, because I really want to have a thorough explanation and a clean code, and to actually have everything laid down for you so you can just understand it and use it afterwards, so you can implement it in your life. So again, I'm trying to respond to as many comments as you add down there, and yeah, if you have ideas, please leave them there. Nevertheless, I hope you liked this video, and I'll see you guys in the next one. Bye.